Hello everybody, my name is Scott Counts. I am a Senior Principal Research Manager at Microsoft Research. I am part of a team called the Urban Innovation Team, which focuses on science and technology for cities. And in particular, we have a strong focus on climate resilience and climate equity in cities. The project I'm going to demo today is called Project Eclipse, and it's a platform for doing hyperlocal or neighborhood or even sub-neighborhood scale air quality measurement in cities. And so that platform consists of a piece of sensing hardware that we have built in-house, and I'm going to show that through a data stack and analytics and different experiences for different constituency groups. So I'm going to start by talking about the hardware itself. I show the sensor. This is the air quality sensor that we have designed and built in-house at Microsoft Research. You can see it's shaped like a leaf. It's about the size of my hand, maybe slightly larger than my hand. And we've worked very hard to make this weather resistant, to simulate airflow so that we get good airflow coming through the device, which is very important for getting air over the surface of the electrochemical sensors inside. Here you see we have an air intake at the bottom of the device. There's vents up top, which are very carefully covered so as to prevent rain and other insects and things from getting into the device. It's very lightweight, weighs maybe a pound or so. On the back of the device, we have a mounting that's extremely flexible. In fact, we went with what we call the zip tie metaphor. You can, in fact, just run zip ties through here to put this anywhere you'd like. We also have some custom mounts that we've designed for different experiences that you can kind of hook in here. The whole thing runs on solar power, so we actually have a solar panel here which powers a battery which is inside. So basically it charges up the battery, which can then run on the battery overnight and then recharges back in the daytime. And we've tested the solar panel even in the grayest of winter days in Seattle, and it seems to hold up very well. This particular design has the solar panel connected by a wire to the device. We've tried other designs where we've had the solar panel mounted directly into the device itself. That has the advantage where everything is sort of self-contained in a single device. This design, though, having it separate means that you can position the solar panel separately from the device. You can angle it to get maximum sun exposure. So this is the device that we have built for doing air quality sensing in cities. I'm going to flip over to some slides now and talk more about what's inside the device in terms of what we sense and then the data and what we're doing with the data. Okay, now we're going to go through some slides about Project Eclipse, starting with the hardware itself. As I was just saying, I can show what's inside the device that we made. Before I do that, though, I just want to make sure to acknowledge the team of people that have been working on Project Eclipse. It's a fantastic, very multidisciplinary team of people, everything from electrical engineering to industrial design to design, social science, chemistry. Really fantastic team of folks that have come together to build this project. Okay, so let's look at inside the device and then also talk about the data stack for Project Eclipse. So here you see a blowout of the device. That's the same enclosure I was showing before. Again, very weather resistant, insect resistant, bird resistant. Worked very hard on that side of things. Inside of the device, you see there we have the red circles are gas sensors, electrochemical gas sensors. So we sense all the components of an air quality index. So carbon monoxide, sulfur dioxide, ozone, and nitrogen dioxide for gases. There's also a particulate matter sensor, so we sense PM1, PM2.5, PM10. You see the battery that's tucked in there, as I mentioned. So the solar panel charges the battery so that the battery can let the device run overnight. The device, and by the way, the solar panel means that no power is required, so we wanted this device to be very deployable for cities. That is, we would envision cities being able to deploy 100 or even more of these around a city, and that's in fact what we're doing in Chicago right now in an initial pilot. So we don't want them to have to be plugged in, so they're solar powered. They also don't require any Wi-Fi, so they're LTE-M connected. So there's a SIM card inside the device so that all data is sent right over LTE every 20 minutes right up into Azure. As I mentioned, we collect all the constituents of an air quality index. We sample at 5 minutes, but we send data about every 15 to 20 minutes. So that's a look at inside the device. Let me talk for a minute about the data stack. So once the data comes in from the device, goes into a full Azure data stack, starting with IoT Hub, ending with a service, basically an API. And that API then powers a bunch of Power BI, custom analytics, and different experiences that we've been designing and that others can build on top of as well. So let's talk for a minute now about when we actually deploy one of these networks of sensors in a city. As I mentioned, we've done this at the largest scale in the city of Chicago in the US. We have over 100 sensors out in the city of Chicago. So to start, let's just compare to some other air quality sensing networks. So each of these pictures is showing Chicago. On the left, we see the EPA, Environmental Protection Agency, regulatory grade monitoring network for air quality. And really, there are actually only 3 PM2.5, which is probably one of the constituents of an air quality index that most people care about in the entire city of Chicago. So it's very high quality, but there just aren't very many sensors, in part because they're very expensive. In the middle, there are crowdsourcing approaches to collecting air quality index. So there's Purple Air, for instance. And these are great that people are doing these. Research has shown, though, that they're not evenly or equitably distributed around a city. So on average, they're in whiter and higher income neighborhoods, the PM2 or the Purple Air sensors. And then on the right, you see our Project Eclipse deployment. So the purple dots are all of our different nodes around the city of Chicago. And we spent a lot of time thinking about how to deploy these in a way that was very representative of all the different neighborhoods in the city of Chicago. So we have, as I mentioned, over 100 devices in the city of Chicago. 80 of those devices were placed using a stratified random sampling technique that ensured that locations were sampled randomly across both high and low traffic and high and low population neighborhoods in Chicago. We also partnered with a number of local environmental justice organizations who gave us local on-the-ground knowledge of where they thought were areas of kind of higher concern for air quality issues. And so we added almost 20 more devices based on their input. And then we have 9 devices that we're co-locating with those regulatory grade EPA monitors in those three different locations in the city, so that we can do calibration of our data. And we have a fantastic set of partners that we're working with in Chicago, including the City of Chicago, a number of environmental justice community groups, as I mentioned, and then JC2Co, who manages bus shelters throughout the City of Chicago, and that's where we're placing our sensors, on the bus shelters around the City of Chicago. Once the devices are out, we want to make sure the data are as good as they can possibly be. So they first go through a quality assurance or quality control QA/QC process. And briefly, what that looks like is that initially we rule out any implausible readings or any malfunctioning devices. And you can see in gray there the percent of readings that meet those criteria are virtually 0. So that's good. And then we have a few kind of thresholds for inclusion of data that we look at for different functions. So for visualization versus for analysis. And again, the percent of readings that fall into these different categories where we have to exclude them are extremely low. So overall, what we've learned from deploying these is so far the hardware is performing just fantastically well. The biggest surprise was actually that we had to move 11 devices, so about 10% or so of the devices, due to poor cell signal in the city of Chicago itself. So remember, these are stationary devices, so if the device isn't quite getting enough cell signal that it can transmit data up into Azure, it needs to be moved. And usually that's actually even more than just, say, across the street or something. It needs to move maybe a block or two away. So that's the QA/QC process. And really importantly is we want to get really good calibration of our data. So again, we're talking about a device that costs a few $100s, and so you want to get the data as close to regulatory grade as possible, and that's why we co-locate with the devices, the EPA devices in the city, so that we can do that comparison and we can train our data against the regulatory grade data to make them as good as possible. And here you see some results. So these are some different models on test data on the right there. comparing our data for PM 2.5 against the regulatory grade data. And you see that, even the raw data does pretty well, but definitely the random forest model and the gradient boosting model also does quite well in fitting on test data, our data against the EPA regulatory grade data. And we're capturing about 85% of the hours that would be considered moderate or hazardous air. I mentioned Power BI sort of at the top of the data stack. Fantastic tool for not only getting insights in the data, but just keeping track of the sensors themselves, making sure everything's running correctly. So we have a device monitoring dashboard. This one this screenshot just shows an example of, monitoring the battery voltage, and then you see that kind of up-down, daily rhythm that I was talking about, where the solar panel charges up the battery, and then it kind of dips down overnight, and then comes right back up. There's the cellular signal for this one particular device that's selected at Central Park in Ogden. And so we've been using Power BI and building these dashboards to really keep track, or help people keep track of the status of all of the devices around the city. Okay, so once we have the devices out in the world, we're collecting data. What are we going to do with these data? Well, we want to build experiences that help different constituent groups, find meaning and find value in these data that we're collecting. So let's look at some of those. So for residents of the city, we have the primary way we have built for folks to interact with the data is through this urban air site. It's designed for mobile use. So at each of the bus shelters around the city, there's a 2D barcode. So it shows a decal and a 2D barcode, which is shown there on the left. And if you scan it, it pulls up the air quality at the bus shelter in real time, where you are standing, and from there you can view the map of the whole city. We can look at any of the locations. You can go back in time and kind of get a history of the air quality data at those locations. You can again view air quality data at any of the places in the city. And then in the hamburger menu, there's a whole bunch of options for learning more about air quality, learning about particulate matter, learning about organizations that are working on these issues in the city. So where you might get more information, where you might want to get involved if that's something that's interesting to you. We're also thinking about some other experiences for other constituent groups, so in particular for community groups. So on the left, there's a couple of screenshots of a beta web tool that we're building that enable people to really personalize the data. So we pull landmark data from Bing, such as schools, gas stations, roadways, and we intersect that with socio-demographic data and with the air quality data so that you can build a very customized sort of data narrative, if you will, such as how does the air quality compare when you're close to schools versus far away from schools, or close to an address versus farther away from an address. And then finally, we're experimenting with some kind of novel ways to engage with community groups. So you see a picture there of what we call EcoPod. The EcoPod is actually formerly a horse trailer that we have outfitted, and we're planning to take it into the communities starting in October 2021 in Chicago. And the idea is to bring it to communities, have some programming, enable people to visit the EcoPod, hold the technology, see how it works, look at the sensors, engage with the data. We'll have some very rich interactive data experiences for people to kind of engage with and just learn about air quality, about technology in cities, and about how that technology can help them and their city understand air quality in their neighborhoods. That was Project Eclipse from the Urban Innovation team at Microsoft Research. We're now going to flip over and show a video that was taken on site in Chicago while we were deploying our sensors in July of 2021 that includes a number of perspectives from community groups and some of our partners on the ground in Chicago. Thank you.
I have had 3 children who all have asthma, right? It didn't have to be that way, but I live in a neighborhood with really bad air quality. And I know hundreds of other children in my neighborhood who have asthma.
We are a major transportation hub, which means that there's a lot of diesel traffic and a lot of heavy-duty equipment for things like construction.
So because we're talking about heavy diesel trucks, we're specifically looking at particulate matter 2.5 and particulate matter 10, which is the smallest of particulate matters that get into your bloodstream and into your lungs. That particulate matter is impacting our community even harder.
Air quality is a great example of an urban problem that impacts everyone. Everyone breathes in and out every day. And we know technology has a really important role to play in understanding air quality and guiding solutions to improve public health and environmental quality.
So Microsoft is putting up a network of stationary monitors on bus shelters throughout the city.
Project Eclipse is a project from a research team called Urban Innovation. The various partners are the City of Chicago, and we're working with folks in the Department of Sustainability, the Department of Public Health, also community groups. We have an incredible partnership with the Environmental Law and Policy Center in Chicago, and we've been working with a number of environmental justice community groups there. JC2Co, who is providing infrastructure in the city, and so it's really just an incredibly rich set of partners, each providing a different aspect of expertise.
So our device has been specifically designed to measure the air quality index, which is a global standardized way of measuring pollution. And so the way we do that is we measure 4 gases, which are ozone, carbon monoxide, nitrogen dioxide, and sulfur dioxide, in addition to PM 1, 2.5, and 10, humidity and temperature. So the unique thing about the Project Eclipse sensors is that they're designed to be as infrastructureless and easily deployable as possible.
We have a device that can report data for 24 hours that doesn't need to be hardwired into a utility pole or a telephone pole that can go up on a bus shelter.
We have over 2,000 assets in the ground that cover the entire cityscape of Chicago. The gathering of this kind of granular level of data, our bus shelters are the perfect vehicle to do that.
We wanted it to be a partnership with people in neighborhoods. So we didn't just want them to tolerate our devices, but we wanted them to really embrace them.
This is huge because a lot of the work in the cities does not involve the community groups at all. And so Microsoft is taking a step back and really involving the community in this process.
With the Microsoft work, it was a way for people to see that something was being done about that. Like there was a space for this data to be collected. They were really interested in looking at the website and seeing, what does my air quality look like here? How does that compare to what it was like last year or other places in the city? So they could get a little bit more information.
The mobile experience is about engagement and action. So when someone scans a barcode at a bus stop, the first thing they see is an option to enter how they feel about the air quality, good, medium, bad. And then they see a map, and the map shows their local, right where they are, bus stop air quality, but also all other bus stops around the city of Chicago. And then there are a variety of options for them to learn more and to take action.
It's essential to be able to translate complex data sets and technologies in a way that's relatable and digestible for people. Because if that isn't happening, then the science can't communicate what it needs to communicate.
This is an opportunity for me as somebody who studies health equity to say, okay, what are the disparities in particulate matter exposure around the city? What is the planning research? What is the health research that is now possible?
Air pollution doesn't stop at the boundaries of our neighborhood. It goes all over the city. And so to be able to actually show all 77 neighborhoods, hopefully at some point, what is in their air, I think is a very powerful organizing tool that we're really excited to be able to expand on.